Okay, kids, we continue with our podcasts on the impacts of climate change. Here I am in Mumbai sitting in the middle of the day and it's the monsoon, but the monsoon has disappeared for a few days, which means it's very hot and very humid again, and I'm running a fan behind which may make a little bit of a hissing sound. But I always check the sound and make sure it's good. Maybe sometimes you will have to use a earphone, but let me know if you're not happy with anything. Okay, so here we will read about the rivers in the sea. You're asking me, what do you mean by that? Well, let's read a story. There's a duck ship that was going along here. They were heading across the water for some little adventure in American bathtubs. So you can imagine they were coming from Asia, likely China, to the US. So you little kids can sit in the bathtub and watch the little ducky running around, floating around, and so on. The container here. But on the way from China to the United States, their ship got caught in a serious storm. The container they were in was swept overboard and the doors swung open and the craters, they were all over the place, bobbing around the middle of the Pacific Ocean. Almost 29,000 plastic bat toys, yellow duckies, green frogs, red beavers and blue turtles. More than 10 months later, a beachcomber on the coast of Alaska found the first 10 animals. Most of them looked a bit pale, but they survived because this plastic is hardy. It doesn't go anywhere once you put it out there in the ground, in the ocean. Sometimes tiny particles in the air, they are staying there forever, and you breathe them. They are in your blood, and sometimes they are in your stomach, and so on. So oceanographer Curtis Ebbsmeyer knew at once that this was an excellent opportunity to find out more about the currents of the ocean. You dump some floating toys in the middle of the ocean, what happens? We didn't know, but then we got this opportunity to look at them. Will they just come straight to the coast of America? Will they go south and go across the equator to Australia and Chile? And will they go into the Arctic Ocean through the Bering Strait here, come all the way across and come through some Fram Strait or whatever strait that is here? You can find out. And come down into the North Atlantic Ocean and maybe go back. So these are the currents in the ocean that we are not always very sure about, because you need a lot of data to see exactly what they are doing. With thousands of bat toys though still out there on the open waves, now the ocean is always bobbing up and down, he started making calculations. This Curtis he's a smart man. He tried to predict where the others would appear over time. An entire herd of toys would probably swim right through the Bering Strait together and get stuck in the pack ice over here. Very slowly the ice would move eastward, and in about 5 years they would likely end up in the warmer waters near Greenland. Oceanographers offered a reward to anyone who found one of these bat toys in the Atlantic Ocean. He was eventually proved right. Curtis found ducks, frogs, beavers and turtles in Canada, Iceland, and later even in Ireland and England. Other toys had floated towards Korea on the other side of the Pacific, and Hawaii and Australia. There must be thousands of them still bobbing around in the open ocean. If you find one, you should drop Curtis Ebbsmeyer a line saying, "Hey, I found a toy from the ocean." Curtis Ebbsmeyer is available at curtisebbsmeyer@comcast.net. I hope this email still works. The Rubber Duckies and their friends were able to travel so far because of the currents in the oceans and because they don't disappear, melt away. But in deeper water, it's mainly a result of the differences in salt content and temperature. What does that mean? If water has a density of 1 gram per centimeter cube, if you add salt to it, Will it get heavier or lighter? It'll get heavier, right? If you warm the temperatures, we said it will expand and the volume will go up, which means the density will go down. So the density of the water depends on how much salt there is and how warm it is. And we have been saying that the ocean evaporates and provides all this water for the atmosphere, for the snow, the clouds and the rain. And we never said what happens to the ocean. We said it loses the energy, so it cools down. But ocean has lots of salt. What happens to the salt when evaporation happens? If you take a little pan and put salt water into it and let it evaporate, you will find salt deposit at the bottom. Similarly, when evaporation happens and only water molecules are lifted out of the ocean, the salt is left behind. So if you evaporate a lot, it will leave behind a lot of salt, and you can make the water very heavy. Where does evaporation happen? Near the surface, which means you're adding salt at the surface, which means if water at the top gets heavy, it's going to sink like a rock, right? That's really amazing. So on the surface the wind provides currents, but in the deeper water it's mainly salt. It's mainly a result of the differences in salt content and temperature. Warm water is lighter than cold water, and fresh water is lighter than salt water. So if water is salty or cold, it can sink. If water is fresh or warm, it can rise. This creates all kinds of currents in the ocean, not just at the surface with the winds dragging it around, but water sinking and rising around the world as well. This creates all kinds of currents in the oceans. Water rises like an escalator, drops like a waterfall, races like a roller coaster, up and down, rushing over and under and through. Where water disappears, new water has to fill the gap. Where the water appears, other water has to leave. So if some water comes in, it pushes out other water. If the water leaves, then some other water will come in. Okay, for those who are old enough, this is called balance. Water mass is balanced. If you remove water one place, another water mass comes in, and so on. Okay, it's a complicated system in which everything is connected to everything else. A change in temperature can have serious consequences, though. You can see this, for example, in the weather phenomenon of El Niño between South America and Indonesia, around Galapagos, where the water is usually cold. Once in a while it gets very warm. Normally the east wind pushes the warm ocean water from Peru towards Indonesia, Australia, New Guinea. This creates space off the coast of Peru for cold water from the deeper sea to come up. That cold water ensures dry weather. Above warm water, heavy showers can develop, but when the east wind drops for some reason we don't know exactly, and happens every few years, then the water is not being pushed from Peru towards Indonesia anymore, so it can slosh back around. Then warm water from the west near New Guinea, Australia, Indonesia, can slosh towards South America, Peru, Australia, and Indonesia get the dry weather because it gets cooler. They are losing the warm water, and this happens in the ocean, but this perturbs the rainfall everywhere. Remember, where the rain happens determines how much rain happens and how much heat is released, how the winds go. So you can change rainfall over India, over Brazil, over Australia and Indonesia and California and Chile and so on because of El Nino, which means harvests can fail and lots of forest fires can break out because Indonesia can get bone dry and the lightning can then start a big fire. Along the coast of South America, though, it becomes warmer and wetter. The sudden rain causes mud flows and landslides. But the consequences of El Nino can be felt elsewhere as well. Drought causes hunger and famine all the way to southern Africa on the other side. An average El Nino lasts around 6 to 9 months before the situation slowly returns to normal. Okay, so here is Indonesia on the western side of the Pacific Ocean in the tropics, and here is South America on the eastern side. Winds are going from east to west, the trade winds that we looked at before, often, sometimes, and often, and sometimes. And that wind is pushing the water this way, so as water is pushed, cold water from below is coming up and the warm water is piling up here. Once in a while, if this wind gets weaker, then the currents begin to go this way, and you can see warm water is spreading over here and the cold water is gone deeper, so gets colder here and gets warmer here. And now the rainfall, heavy rainfall that's here, moves here, and was sunny and dry here now becomes sunnier and drier. The rainfall doesn't completely disappear necessarily, but it reduces quite a bit, causes droughts and dry and dust storms and wildfires and so on. So that is El Nino. Why is it called El Nino? Because in the 1800s, when the Spaniards went all the way to South America and colonized the land, they noticed once in a few years around Christmas time, this nice warm water comes along the coast where it's usually very cold. And they were happy. They thought this is a little gift from Jesus Christ. They called it El Nino, which is a Spanish word for the child. Nino is the boy, little boy, or the child. They called it the Christ child and said the Christ child around Christmas is bringing a gift of warm water. They didn't know how many bad things it does. Just locally they saw that water was warm and rain came, so they were happy. Okay, however, changing currents can have other consequences as well. Some scientists say that Europe will become a lot colder because of climate change. What? Huh? Colder because of Earth warming up? They are talking about the warm Gulf Stream, which is in the Atlantic Ocean. At the moment, this ensures that winters in Amsterdam and London are much milder than winters in New York and Toronto. New York and Toronto are on the western side of the Atlantic Ocean, and Amsterdam and London are on the eastern side. If a warm water flows from west to east, it's bringing warm air and humidity and drizzling rain. Sometimes London can have days and days of cloudy, drizzly weather which can make you miserable, but Toronto and New York can have miserable, cold, windy, snowy winter as well. Okay, so they are basically further south, both New York and Toronto, but they get cold weather from land. This is because the ocean currents carry water from the Gulf of Mexico all the way to the northern Europe. Near Greenland, the water cools off. As a result, it occupies less space and becomes heavier, and it is evaporating, so salt is collecting in the surface and it becomes heavier and sinks to the bottom. The cold water flows back along the American coast to the south as an undersea river. So there are these rivers of currents in the ocean with different temperatures and different salt amounts and so on. In recent years, the Gulf Stream appears to have been getting a little weaker, which means it's not moving as much heat from the tropics to the Greenland area. This may be because so much ice is melting in Greenland that the fresh water is disturbing the Gulf Stream. If water wants to get heavier, evaporate and sink, but if you put a lot of fresh water, and the salt is less, so it's not heavy anymore, it's lighter. The fresh water floats on the salt water and stops the current from sinking, and that means new current will not come to replace the sinking water. If the warmer water can no longer reach northern Europe, it could become 10 degrees colder there. It would not be the first time that a big dose of fresh water has disrupted the Gulf Stream. In fact, 10,000 years ago, an American glacial lake, remember 12,000 years ago, and before, we had lots of glaciers on North America, and one of them melted and it didn't all flow into the ocean because some piece of the ice was holding it like a dam, and then the dam broke and all that melted glacier water suddenly poured onto the North Atlantic Ocean. So that lake emptied and half of the world was suddenly plunged into cold. If you are old enough to see a movie, you probably want to go and see a movie called The Day After Tomorrow. If you follow it, you will see that the scientists are reporting that the temperatures are very very warm in the North Atlantic around Greenland, and the next thing you know, the hero and the heroine are freezing in a library in New York. That's how it happened. If it gets very warm, you can see this image here. I'll pull up. Okay, I hope you can see it. Let me make it a full screen. I hope you can see it. So this is warm low latitude water in the Atlantic. Here is the Gulf of Mexico. So warm water is flowing north and across between Florida and Cuba. Here it's called the Florida current, and then comes up and hugs the coast and goes out here into the Greenland region, and you can see it begins to cool off. This is bringing a lot of heat here, so this place is not getting any heat. It's cold. New York is up here, Toronto is up here, so they are freezing. They are getting weather from the land, whereas the winds blowing this way are bringing nice warm humid climate to London and Amsterdam. Okay, so this, how much water can come up here depends on how much water is getting heavier here and sinking. If global warming and the melting of Greenland ice makes fresh water and reduces the amount of water sinking, then this current is not going to bring that much water, and that means less heat is going to come into the North Atlantic. Okay, sounds complicated. Maybe you are not old enough to understand all that, but just remember Gulf Stream and weather over New York and Toronto versus weather over London and Amsterdam. Maybe you are from there, or maybe you plan to visit there. Maybe your parents can explain where they are and what they are doing. So learn as much as you can. Don't panic if you don't understand everything. Okay, we'll come back and look at the next topic, which is acid oceans. As we keep on increasing CO2 in the atmosphere, what happens to the ocean? You know that CO2 easily dissolves into water. That's how we get our Coca-Cola and Pepsi and Thumbs Up and soda water and so on and so forth. We'll come and discuss that. Okay.